Hello and welcome to Web Math Academy, where today we're going to discuss again Newton's root approximation method. You may recall in last week's tutorial that we learned how to do that by hand, and that we drew a little graph which showed our function curve in blue, 0.1 x squared minus 1, and then we showed you how we can get the derivative of that function and come up with a tangent line, a slope that's tangent to the curve at x equals 10. And then we could come up with the next root approximation of 5.5, then put that into Newton's equation, come up with 3.65909, and so on and so forth until we get to the conclusion, our solution of 3.162. Today we are going to use our TI-Nspire calculator and write a Python program which will do this automatically for us. Before we do a program, it's sometimes useful to draw a flowchart just to show us exactly what we're going to be looking at and where we should go forward with writing our program. The first thing you need to do in any flowchart is enter the input function, and in this case we'll be getting our coefficients from the program, a, b, c, and d, and then we'll enter our initial root guess equal to x. That's going to be 10, just what we chose last week. Then we'll calculate the derivative of the function. And finally, before we start the loop, we'll obtain the initial conditions, such as the iteration, how many times we're going through the program, and then how precise do we want our answer to be. In this case, 1 times 10 to the negative 9, about 9 digits, 9 decimal places. Once we have that information, we're all set to start our Newton's root approximation. x1 equals x minus the function divided by its derivative. After we calculate that, then we calculate how precise we're at, how close, and that's going to equal the absolute value between x and x minus 1. If that answer is precise enough for us, that is if how close is less than the precision that we asked for, which again is 10 to the negative 9th, then yes, we will get our answer, we will display it, and that will be the end of the program. However, if we're still not as precise as we'd like to be, then we go to the next step. How many times have we tried to get this answer? If it's over 100 times, chances are something is wrong, and we're going to say the method failed to converge, and we're going to end the program. If none of those is correct, we'll reset our initial conditions to x equals x1, and iteration equals iteration plus 1, and then we'll go all the way back up and recalculate Newton's approximation. So that's the flowchart. Let's take a look at the program that we wrote. So here is the Python program in your TI-Nspire calculator, and we can't actually show the whole thing at once, so I'm going to have it up here on the right side of the screen for you. This is it. This is the whole program, 19 lines, and this will automatically go through as many iterations as necessary to get as close to precise of a value as we want to get for a function's root. And you can just type this directly into your calculator. Let's try to run it and see what happens. To run the program, you hit menu, and you hit number 2 for run, and you hit number 1 for run again. And here's where it's asking us for our coefficients. This would be the a, b, c, and d over here. For x cubed, we're going to use that same equation we used last week. So our x cubed equation will be 0 coefficient, x2 will be 0.1 x squared, x 0, and our single digit coefficient is going to be minus 1. And it's going to ask us for our first approximation. We'll use 10 just like we did in our graph. Enter, and just like that, it comes up with a value we want to the decimals, 8 decimal places that we were looking for. It took only 7 iterations to get it within that value. Now you could make your own changes to the program to do even more. For example, higher order equations, x5, x to the 6th power, or whatever you want. Also trigonometric functions could be done. Sines, cosines, sine squared, you name it. Texas Instruments has put out a really good tutorial on the use of Python, and there's a link over here on your right that I highly encourage you to try it. And if we get an opportunity, we'll also give you some more step-by-step information on exactly what every line in this program is for. We're glad you spent some time with us. We encourage you to have some fun with this program and try all kinds of different functions and see what you can come up with. We'll talk to you in our next tutorial.